Hey everybody, back out here in the garage today, working on my 5.1 liter stroker Texid block. I gotta kill that speaker. It's doing weirdness. Alright, one thing that's been messing with my brain and bothering me a little bit is I've been trying to figure out what compression ratio that I'm going to end up with when this is all said and done. I know several variables to figure that out. I know the stroke, I know the bore, I know the piston dish volume, I know the piston to deck height, volume. I think I can figure out or find out the gasket compressed thickness, which is minuscule, but it is extra volume in the combustion chamber. I also know the head combustion chamber volume from the manufacturer. So I have all those variables except for these pistons did not come with these valve reliefs fly cut into the pistons. So I've watched some YouTube videos and other things, and done a lot of reading about how people do that, how they measure those. And most of the time, it seems like people buy pistons that already have that done from the manufacturer, so it's figured into that piston dish volume, either negative or positive, and it's provided to you as a spec from the manufacturer. When I look up these part numbers, these are older pistons. When I look these up, and I should also add that I did not purchase them. I bought them from the guy that bought them originally. So when I look up the part number, all I can find is the old information online for the dish volume from Probe Industries, which is what I'm thinking these are. So when talking to the guy I bought the car from, he did say that he had them fly cut like this. And I didn't know if that was true or not, but from everything I can tell, what he's said and everything he's told me from then on, from that point or that day, it has basically been validated or verified based on my research and what I've been able to find as I've been doing this build. So these don't come with fly cuts in them, or at least they didn't back when he purchased them. So those were done by a machine shop on a jig of some kind. So I've seen people do, similar to what they would do with the combustion chamber on a head, where they level it and fill it up with a fluid, water or whatever, minerals, spirits, or oil or whatever. They'll have a piece of plexiglass over it with a hole drilled in it so that the extra can flow up out of it. And they measure the volume that way with I forget the name of it. It starts with a B, a little chemistry tool. But I've also seen somebody do that with the piston, but they used denatured alcohol because that won't strip the stuff off your cylinder walls and stuff. But the drawback is you got to work quickly, and you got to want to deal with that because it evaporates very quickly, and I don't really want to mess with that. So I've been toying with different things in my mind of whether I should even worry about it or if I should just guesstimate. Are these 2 cc's, 3 cc valve reliefs or what? I'll give you an idea of how large we're talking about here. So it's not like there's a ton of space. These are real small, so I would be surprised if we even get a cc out of both of them combined. So these piston tops have a 13.5 cc dish to them, and I want to add whatever's necessary to compensate for those valve reliefs so that I can actually determine exactly what my compression is going to be. I don't want to be guessing like, oh, it's somewhere between 10 and 10 and a half. Just guessing on the gasket thickness, I think it's going to be somewhere between 10 and 10 and a half. But I also guessed on the valve reliefs being 3 cc's, so I don't even know if they're that big. So I want to know the number, and that's just my own pickiness coming out, I guess. So anyway, I decided that I could probably utilize my plumbing putty again. So I'm going to go ahead and do that. And just going to get a little piece of that putty, and I'm going to put it in those valve reliefs, and I'm going to shape that just the best I can to the shape of the rest of the piston dish, so that it's as if those valve reliefs are not there, and it's just follows the contour of the rest of the piston. And once I get that, any excess out of there, and it's just filling those valve reliefs, then I'll remove those little chunks of putty, put them together. Again, this is as close as I can get it without messing with alcohol and liquid and stuff. I'm going to put those little pieces together, roll them in a little ball, and then do some math to figure out the volume. I'll measure the ball, I'll measure the diameter with a micrometer, and then I can determine the radius, by dividing that in two, and then I can do some I forget which one it is, geometry or whatever. Anyway, I'm going to figure out the volume of the sphere by doing the 4/3 times pi r cubed. And that'll give me my cubic inches of the little putty ball, and then I'll convert that to cubic centimeters by multiplying it by 16.387. And that'll give me how many cc's I'm dealing with, and then I can put in the correct variable in my equation. So here we go. All right, get some putty out of here. It's trusty plumber's putty. Stuff is great. I'm finding it has far more uses than I ever knew. So again, I'm just going to use little tiny pieces, and I don't think it's going to take that much. So I'm just going to put this in here, kind of mush it down. This was a pretty cool idea, I must say. Okay, I got it most of the way in there. Look at that, this is going to be great. Oh yeah. I want to be able to tell the people that are going to dyno this exactly what my compression is, so they can start off as safe as they need to, All right, we're getting close on this one. I'm going to lick my finger here in a second, just to keep it from sticking. This will get us closer than me guessing. Okay, there's one. The next one's even smaller. Yeah, like I was saying, I'd be really surprised if we even got 1 cc out of this all together. But hey, they're concerned about gasket crush thickness and piston to deck height, which seems pretty minuscule to me. And this seemed like a good way to not get a mess all over everything. It's gonna put you on pause till I get this dialed in just right. Alright, so I got those done. So I'll just get you down here a little closer so you can see it. So I just shaped those the best I could, you know, not exact, but it's as close as I can get, just to the contour of the rest of the piston so I can see how much was taken out by that machine shop. So now I'm going to put the rest of this away, and then I'll have somewhere to set my little sphere in a minute. Okay. Got my micrometer ready. It's all zeroed. So I'm going to pull these out. Oh yeah, we're not even going to have a CC out of this. Very little. But it could be as much as, you know, the deck height clearance from the piston, which would be as if I wasn't, you know, if I didn't worry about this, it'd be like me not worrying about that, and I did worry about that. So I got it all here. That's my little ball right there. Tiny little ball. That could be the difference in 10 horsepower right there. No, I'm just kidding. I'll try to get this as spherical as I can. That looks pretty good. Looks pretty good, huh? A little sphere. I'll take my micrometer, set to inches. Just going to back that out. I may end up actually writing this stuff down. It's probably a good thing. Okay. We'll measure it and I'll write it down. Oh, it's right there. We're at 1/4 of an inch. close, you know, but we're going to go with that. 0.27000. 0.27 inches in diameter. Okay. You get a piece of scrap cardboard or something. I'll write it on the inside cover of my magazine here. 0.27 inches diameter. Okay. Okay, I'm gonna go valve relief 0.27 inches in diameter. And I need to divide that in half, so that's going to be 0.135 is the radius. So that'll be 4/3 times pi r cubed. So 4/3 times 3.14159 times the, tell you what, I'm gonna just, yeah, the radius 0.135 cubed. 0.135 cubed. All right, so here's what it came up with, and don't pay attention to this. This is just something I wrote down at the very beginning, but I got my stock bore here and my stroke. So figuring out the compression ratio is just a fraction basically of the cylinder volume, the total volume, basically adding up your cylinder, your deck height, your gasket thickness, your combustion chamber, and your piston positive or negative dish. So basically a total volume as a ratio over the total volume, with the exception of leaving out the swept volume of your piston, because this is with your piston at the bottom, and this is with your piston at the top, and there's a ratio between the two. So I've gone through and got all the measurements, converted them all to cubic inches. You know, it's got my swept volume, cubic inches, deck height, gasket thickness, combustion chamber volume, and then my piston dish, which is a little bit complex because I have there's material cut out of the top of the piston which creates, or it's a positive volume in the combustion chamber, and then I have those little valve reliefs that I've figured out the volume of those. So basically have my valve reliefs in let's see here, cubic inches, which are super small. So I added those together, the factory spec'd piston dish plus those valve reliefs is a total of this volume in cubic inches. So once I got all those variables, then I could go ahead and plug those into my equation. So went ahead and did that, added them all together, and ironically enough, it came out to 10.0001 something 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 to 1 compression, which is cool. So 10 to 1 compression, and
297.27 cubic inches at 4.871 liters. So that was a little confusing to me because, you know, this is supposedly the 5.1 liter stroker kit. Well, that's what the machinist told me based on just some research that he had done when I gave him the block and, you know, with the crank and the pistons, or the block and the crank and stuff. So doing a little more research on my own, I found out that the actual 5.1 liter strokers usually come with an overbore of some kind. Some people are saying 60 thousandths over. Some are saying 30 thousandths. Maybe the 60 thousandths have sleeves in them that are made to handle a larger bore like that. But this is the 3.75 inch crank stroke and the stock bore. So I have a 3.552 inch bore. So given those values, I actually get 297 cubic inches. So I am not a 5.1 liter stroker. I'm going to have to stop saying that in my videos. I'm going to have to say welcome to my 4.871 liter stroker video. So anyway, kind of cool stuff. 10-to-1 compression, just under 300 cubic inches at 4.871 liters. Pretty cool. So now I got to talk to the machinist and see, you know, what he recommends on the compression, and see if he may need to mill the heads or something of that nature. Cool stuff. See you next time.